Hey, it's great to be here. Thank you for inviting me. I'm Nick McKeown. I have a day job of being a professor of computer science and electrical engineering at Stanford. But I'm here representing the p4.org open source and language group who has been developing P4 as a language for expressing forwarding planes. I'm also going to be talking about some of the things that Barefoot has been contributing. That I'm a founder and on the board of Barefoot Networks. So if you think about it, when you're building a network system, you're developing a network operating system, as we're discussing here, but it's got to run on hardware. It's got to run on some platform, some target. And the problem is that when you're building a piece of equipment, that hardware target could be a number of different types of pipeline. So it could be a fixed function pipeline, as is typical in top-of-rack switches in data centers. It could be configurable. It could be an NPU. It could be an FPGA. It could be a software switch. And the issue when you're developing a network operating system like OpenSwitch is that you have to figure out what you're going to be testing it on, what you're going to be developing it for. So we thought it would be useful to express that pipeline using the P4 language, which is designed for describing how forwarding pipelines should work, or describing one that already exists, and then generating an executable switch that can then be used for developing OpenSwitch against and testing against. That way, if there are other switches, whether they're fixed function or programmable, they can be expressed in P4, and it allows OpenSwitch to be developed and tested against a number of different pipelines and forwarding planes. And without having to use a neutral open source switch like OpenVSwitch, which after all does not represent the forwarding pipeline of any particular hardware switch. So it gives a more general way of expressing these different forwarding planes. So to refer to these slides, to help with that, Barefoot then contributed the framework in order to be able to generate that forwarding pipeline to then put into OpenSwitch. There was a demonstration that was done at ONS in 2016, demonstrating a couple of switches that were using a P4 forwarding plane. The description of that forwarding plane is described in an open source P4 program called switch.p4, which you're welcome to take a look at. It's at p4.org. It'll tell you about the features and functions that are in that particular switch. And then that generates an executable switch that OpenSwitch can then interact with and control. This particular demo was showing that with BGP running on top and et cetera. But the idea behind this is once you've got this expressed in P4, you could then replace that P4 program, switch.p4, with one that represents a fixed function forwarding plane from a fixed function ASIC that already exists, and therefore allowing the testing to move on more easily without then having to redevelop it and the APIs for a whole load of different forwarding planes. So it allows rapid prototyping and testing, and that to be extended over time as well. So as new features, you want to test new features that you want to put into OpenSwitch, then you can test them out against a forwarding plane that has been defined in P4 to allow that to be tested. So, and in principle, once you've got that tested in OpenSwitch on that P4 representation, it should be very easy then to migrate it to work on any switch forwarding plane that has been expressed in P4. So it allows for easier migration across these different targets, whether they're fixed function or programmable. So just to sort of explain that a little bit more detail, you start with a P4 representation and then could, for example, compile that to an FPGA-based switch, an NPU, or to a leaf and spine switch represented on a fixed function ASIC, even to a network interface card, like some of those are becoming programmable now. There is a P4 front end to OpenVSwitch, so you could use it to configure it to OpenVSwitch as well, or to a kernel networking stack. There are a number of companies, as you may know, that have been interested in P4 and using that as a way of expressing the forwarding planes, either that they're using or that they're developing. So it seems to be a useful component for OpenSwitch. And the idea is that with OpenSwitch, not only does it provide a way of helping OpenSwitch, but OpenSwitch being available as a complete network operating system, it allows more development of P4 and of different forwarding planes as well. So they go hand in hand, and they're very work very nicely together.
Good afternoon, everyone. Thank you for inviting me. My name is Eli Karpilovski, and I'm from Broadcom. At Broadcom, I'm responsible for the software that runs on top of the Broadcom switch silicons, XGS and Dune. And most of my projects today are evolving around open ecosystem, SDN, and cloud. A lot of the, when I'm looking back a year ago, I think more or less a year ago, the request, we kind of rolled out a project named OpenNSL, Open Network Switch Library. And at the time, it was designed to open up a bunch of APIs for a specific, I will say, open OS. Need to move on to the next slide. Thank you for reminding me. This is my slide. And the HPE at the time, HPE came to us and said, hey, we need your help. We want to make sure that the OpenSwitch operating system works on top of Broadcom silicon. And so we immediately said yes. And we start working with the team. At the time, there was about 96 APIs that were open through OpenSL. Today, 4 releases later, we have about 500 APIs. And we believe this is probably everything that you need in order to develop and design a modern and efficient network OS for the cloud, which that is what OpenSwitch. We believe that OpenSwitch is a very good open OS. We are investing a lot of our resources into this. And as you could see, we pretty much took every open initiative that we had and find a way to integrate that into the OpenSwitch. So the first example that I gave was OpenNSL. That was the enabler of how to run quickly, turn from requests of new APIs and new functions of the network OS to a API that could be supported on the silicon, to things like Broadview, which I will talk about in a second, and very soon OpenFlow. I think some of the people in the room here kind of helped invent OpenFlow, and Broadcom is definitely took this seriously. And today we have a platform, or we have a software that enable a lot of the ecosystem partner of ours and our customers to take existing silicons already deployed in the data center and in the service provider markets and use them using OpenFlow. So I think I'm very proud to say that we're probably the first contributor of this project. Correct me if I'm wrong, Michael, but I think we're the first contributor of this project. We started by providing the OpenNSL layer. As I mentioned before, we provided this layer to enable, to foster innovation on top of it, and we provided the OpenNSL layer, and it enabled all of the additional functions, APIs, and services that needs to be running on top of it. In addition, we've been working very closely with the ecosystem and the industry to develop what we call a programmable instrumentation tool, and that is the Broadview agent. And the agent was designed to look at the data center as a whole and say, okay, in this aggregated environment where you have multiple boxes, multiple OEMs, multiple platforms, how can we establish a language that will work from the network OS up to talk to multiple applications, the same language, and help to solve some of the most, I will say, challenging data center problems, day-to-day problems. And the Broadview instrumentation daemon, the first daemon that we contribute, was integrated into OpenSwitch to the OVSDB structure, and I think it's already integrated into the OS, the GUI, OS GUI, the web UI of OpenSwitch, and provides statistics, information that you could use to extract congestion notification, things like packet tracing and other functions that we plan to add in the near future. And that's already supported, provided, and integrated in the OpenSwitch. We're very proud of it, and I think this is the first contribution to the project. We're not going to stop there. We're going to continue and invest in this project as we invested with other projects, open source projects. The second coming project is around OpenFlow. As I mentioned before, we have a layer called OFDPA that maps OpenFlow to the silicon APIs. The reason why we designed that layer is to efficiently help our partners use OpenFlow when they try to scale their data center with an SDN controller and OpenFlow, and so they could better perform. So that implementation was, this is a project that we've been working on for about 4 or 5 years. There was one challenge that we had to handle, and that was either we work as a standalone implementation of OpenFlow, or we use a traditional network OS. I'm very proud to say that in the near future, in the coming release of OpenSwitch, we're going to enable what we call a hybrid model for OpenFlow using OpenSwitch. And OFDPA will be the first implementation of OpenFlow and integrated into OpenSwitch. We already have several use cases from simple layer 2 VLAN bridging to overlay that you could provision using SDN controller using OpenFlow. And that is one other thing that we contribute, and we're very happy to be part of this family.
Good afternoon. I'm Albert Fishman from Cavium, from Technical Marketing Department of Switching Group. And I would like to share with you our vision, our view of OpenSwitch and how exactly we contribute to OpenSwitch, and where, from our side, we see this project may go from, from the industry perspective. So from our side, we are very excited to join OpenSwitch product, at this time when it's a developing, evolving product, because we feel that we can, on one side, we can impact, we can affect the development of the OpenSwitch, and we can also do things the right way on our side, in such a way that we can truly expose all the capabilities of our hardware to OpenSwitch controls, or through OpenSwitch APIs to the operators. In comparison to, if you try to merge two already existing softwares, kind of patch them, it's always suboptimal solution, which is not the case now. So the way we have decided to integrate our SDK with OpenSwitch is a direct integration. We are not going through OSI or this kind of interfaces. We do direct integration, very similar to Broadcom solution. We also expose a upper layer of our APIs, similar to OpenNSL. We call it the OpenXPS. So all this code that we contribute for integrating with OpenSwitch, as well as our open APIs, are available in the GitHub or on the OpenSwitch side. And all this code is available now, so you can just go and compile and take a hardware box and it will work. In terms of hardware availability, so we have everything. We have our chip. This is a production version of the chip. It's available. We have a Acton box. This box, it's a OCP design, also available. Feature-wise, pre-deal features, that was called the Cilantro release, so we support all these features already today. For deal features, we are at the same stage as OpenSwitch. We are QAing the features. The feature freeze just happened last week, so we are also in this QAing phase. And going forward, we're definitely very interested in contributing more advanced features after these basics are in place. So as I mentioned, our chip and the hardware boxes, everything is available already today. So looking to the future, the way we see it is that this combination of a modern state-of-the-art operation system, open operation system, will architecturally allow us to truly expose all the hardware capabilities of our switch. And OpenSwitch as an operation system, as well as operators, will be able to fully utilize the capabilities of our very flexible hardware. That's a very good architectural solution for us, the way we see it. Looking into areas that we think that we can contribute to OpenSwitch or slightly differentiate, we are focusing now on improving the performance aspects of OpenSwitch solution, scalability of OpenSwitch solution. The programmability and flexibility of our device allow us to load on the same hardware and using the same software completely different profiles, when the pipeline, as well as the resources associated with that pipeline, can be optimized for specific place in network or specific deployments. And this thing we're also going to contribute to OpenSwitch. Other things that we think that this combination of OpenSwitch with X-Client architecture, programmable switch, will be very beneficial is extensible tunnels that we can support, as well as the traffic visibility and instrumentation support, which is probably the hottest thing in data center today.
So my name is Amit Katz, and I'm from Mellanox. I would not talk about technicalities, and if you have technical questions, I'll be very happy to answer. I'm running the Ethernet switch business for Mellanox, and I'd like to talk about the business and how we help OpenSwitch being more competitive. I think that we all of us, we have companies, with very smart engineers, they will manage to do this interface and that interface. The innovation in the Ethernet space has not been dramatic, as we can see in the last 10 years. There are not too many protocols and stuff, and all of us kind of catch up, and the silicon is capable of doing all of this. But I think that open source and OpenSwitch doesn't mean compromising. I think that people will look at what there is today out there, and people will say it works, it's great, they can go very low on pricing, and the question is, why would we go and do something else? And I think that Mellanox can help. We believe in open, we believe in this project. We were very kind of key part of these discussions about ONI and openness and all this stuff. Today we're shipping with Cumulus, tomorrow we're going to ship with OpenSwitch. But this thing is really important for Mellanox, and the reason we love these projects is because at the end of the day you have single software with different hardware, and people will ask, okay, if this is the same software, what's the difference? And the difference is not losing packets. Yeah, 2544 was built in order to test whether a switch is losing packets or not. So these are important things that Mellanox will bring to the table. When you talk about buffers and fairness, when you talk about latency, cut-through latency, people don't want to do store and forward, they don't want to do cut-through and decent cut-through. So I think that the role that we see at this project is to bring more to the table, to bring a better AC capability into this project and to make it much more competitive. So this is Mellanox. We are working with the team, whether it's SI or not SI, and all of this. I leave it to other people. There are many ways to get to the same place. There are hybrid ways. But yeah, I think the main goal is to make it more competitive. And once OpenSwitch is out, GA running, we need it to perform the best way possible and to be competitive and to beat closed, old-fashioned, locked solution, because it's not only open, which is always great, but it's actually better. Any questions?